Thank you everyone for joining in on a Sunday, and we'll be getting started with Keras CV, especially in the field of computer vision, and how we have evolved from Keras that was back in the era of TensorFlow 1, and how we have evolved in the era of Keras 3 with Keras CV and Keras NLP. So Usha covered a lot many things of Keras CV that are also similar in Keras NLP and are under the same umbrella of Keras 3. So I'll take you first through a little bit things about Keras 3, which fits basically both Keras NLP and Keras CV. So as I told you, Keras 3 is a full rewrite of Keras. So if you know from the era of TF1, there was a lot of tech debt that was related to Keras in the earlier versions, and it was not really kind of efficient, to be honest about. The code base was pretty large, so around 135K lines of codes that were smashed down to around 43K, around 3x smaller in the era of Keras 3. And Keras 3 has some great speciality of hosting and supporting multiple backends. So earlier in the times when we used to think about writing a code in TensorFlow or writing a code in PyTorch, we had to rewrite the whole lines of code. Like if you have a whole working code in TensorFlow, it was a whole hassle to run the same code in PyTorch or in any other backend. So Keras 3 has come with an amazing support of multi-backend, and it kind of seamlessly blends into it, and you don't have to like rewrite a whole bunch of code for that. And it is also supported for NumPy backend for inference only for NumPy. And you can call it as a drop-in for a replacement for tf.keras if you've been using it for a long time or so. And of course, it works seamlessly with Keras NLP and Keras CV. A shout out to slight courtesy from Aritra and Akash. They are both MLGDs and have been contributing to Keras ecosystem for quite a while, and to this presentation as well. So why you should use Keras 3? So the reason is that why you should jump to Keras CV or Keras NLP and under the umbrella of Keras 3. So first thing first, one API for every major framework. So it avoids like fragmentation of ecosystem. Switch easily into multiple frameworks. You can easily develop some most intuitive ones, and you can deploy in a fastest manner. You have some keras.ops packages to mimic NumPy APIs, and it also contributes some internal functionalities for the neural networks to deploy on. In short, it's highly customizable. Then what is one API? To be honest, it's just simple as writing these 4 lines. So you import OS under the environment of Keras backend. You tell them which kind of backend you want to use, and you just import Keras. So Keras by default knows what kind of backend you're going to use. And using one API like keras.ops.numpy, you can use it for multiple backends as shown. So what are the advantages? Already talked about. Keras supports cross-framework data pipelines. So if you are already working with Keras or you have worked with in ML or DL, you must have worked with these pipelines, especially data pipelines called tf.data.datasets, torch.utils.data loaders, numpy arrays. If you are active on Kaggle, you might be aware about Panda data frames. You might be working with Panda data frames, those CSV files, pd.read CSVs and everything. And of course, another advantage, as Usha already mentioned, Keras 3 has support for lots of pre-trained models. Bit limited for Keras CV as well, but yes, these given pre-trained models are quite useful. At least they cover the basics well. So if you want to just give it a try or feel like a playground to play around with things for classification, object detection, and all, pre-trained models are self-sufficient to help you around in Keras CV and NLP cases. Progressive disclosure of complexity. So basically, when we talk about complexity, is that Keras 3 documentation and how it's built is such that it's divided into levels. So you may be a person who does not know anything about ML and you still want to play around with it, like use a pre-trained model, throw some data in, try some classification, maybe cats and dogs classification, or maybe you just want to detect an object in an image and you're not really familiar with the environment, but you can just take a pre-trained model, throw in the data and get the output. Then you might be a person who knows ML and DL bit well, maybe the intermediate level, and you might want to use some pre-trained model uh, that are hosted for you, and you might even want to use them, pre-trained model, fine-tune them, and use it according to the data needs that you have. And finally, you may be an advanced level person who knows in and out of Keras, have worked along, and you might want custom models for your particular data set and you want to work around even with linear time complexity, right? Then it introduces new stateless APIs. So it really concerns around JAX, if you have some understanding of JAX. So it introduces new stateless APIs for pure functional programming. And of course, it makes distributed training as easy as non-distributed one. So finally, this was a brief introduction to Keras 3 and how uh, it's on the top of the umbrella or in the top order, and followed by Keras CV and Keras NLP. And you've already learned a lot about Keras NLP and you're good to go for the basics of that. So we'll be covering the basics of Keras CV, and just to make sure that you have few hands-on and you take back some of the projects that you would like to try on, maybe the basic ones, and you'd be good to go. So Keras CV, as the name suggests, is a library for computer vision, supports TensorFlow, JAX, PyTorch, and is built on Keras 3. Simply like you did for Keras NLP, you would do update for Keras CV and Keras as well. One thing I like to mention over here is a problem that I faced recently was that if you're gonna use Keras CV, it is supported by certain it is supported by certain upgrades of TensorFlow. So not every package of TensorFlow is supported. So if you want to run Keras CV, you must have TensorFlow of around version 2.14 or above. So 2.14 is the latest one, I guess, followed by 2.15. I don't know if it's fully functional or not, but yes, that's the latest one. If you want to run Keras CV, you have to be upgraded to that level. And otherwise, it won't run. It would be incompatible for that. So make sure if you're running Keras CV, you are updated with TensorFlow and Keras as well. For Keras, it's, I think, 0.7.2 version of it. Then pre-trained models, of course, we're talking about computer vision, and we very well know that most of the data sets that our pre-trained model are trained on is ImageNet. It's a huge data set containing lots of images that it's trained on. So EfficientNet, these MobileNet, ResNet, these are few of the pre-trained models that are quite old, but they work really well in at least the simplest forms and have been trained on ImageNet dataset. So if you are working on some B-style architectures, you might go for EfficientNet v2. If you are working around on like optimized mobile devices, you might go for a MobileNet v3 model. And of course, if you want a ResNet, it has its own pros and cons. Of course, YOLO v8, if you are very familiar with object detection, it's trained on COCO dataset, and it's mostly used, YOLO dataset is mostly used around in object detections for at least the proof of concept purposes and in production levels sometimes as well. And not related to that, I've seen that more and more pre-trained models have been added. I think the SAM model is also being added to this these list of models, and along with that, maybe clip model would be added as well. So seamless switching, we have already seen you just have to switch between TensorFlow, JAX, and PyTorch. It's as easy as just switching or changing the name, and Keras follows what kind of backend you want. So no more hassle of rewriting codes from TensorFlow to PyTorch to JAX. You just need to change the backend once and run it, so it automatically understands the kind of backend you're using. Some key features. So Keras CV offers lots of models. We have already seen the pre-trained models it offers, the metrics, callbacks, and more what can be trained upon, and without any costly migrations, of course. It assists in common computer vision tasks. So, of course, if you are very well familiar with computer vision, you might be familiar with data augmentations, rotating, flipping data, cropping, resizing, classification tasks, object detection, segmentation, image generation, and all. So one key feature about Keras CV is that there used to be a lot of hassle when it came to object detection or writing the whole lot of code about object detection and segmentations. But with latest APIs that have come with Keras CV, it is as easy as writing a single line of code, and you can run it in instant of seconds. So it has boiled down those 5-6 lines of code into just a single line of code. It makes your work even easier. Then, leveraging Keras CV to quickly assemble production grade and state-of-the-art training and inference pipelines. So I have not really put this thing into production, but yes, it says that it can be easily leveraged to do so. So if you remember, in the past days, we would use from TensorFlow import Keras, and you no longer need to do that. So what you used to do is we used to say import TensorFlow as TF, then from TensorFlow, we used to import Keras. But simply now you can just do is from Keras CV.backend, import Keras. It's as easy as that. And of course, as I told you already, Keras CV has few APIs and packages that it has already for you. So rather than writing a whole code for creating bounding box, you can just import bounding box or import visualization to run in your code. So it makes your work a whole easier. Key components we'll be talking about in computer vision. Of course, computer vision boils down to images and videos. So you might want to classify cats and dogs. You might want to detect some object in an image, maybe Taj Mahal in a given image. Then image augmentations. So we are all familiar with how machine learning models can overfit sometimes. We are all heard of the term overfitting. Your model is overfitting. And sometimes we have to do data augmentation to overcome that overfitting. And sometimes we have less data on our hand, and augmentation really comes in handy rather than just collecting more data for your use case. Then semantic segmentation. Segmentation is something that is in the market recently. And if you're familiar with SAM models from Meta, that they have been really up to the mark for segmentation. Then is image generation with stable diffusion. That is one of my favorite topics to cover on. I've been working with stable diffusion, especially from Hugging Face stable diffusers. And this is something that we really use if you have used Gemini recently for text to image or image to image generation. So it uses stable diffusion in backend. We look into all these components one by one. So first up is classification problem. Classification problem, as you all know, is basically you want to, given an input image, you want to predict a categorical label, and Keras does it pretty easily. Most of the classification problems are easy, say binary classification, but when it comes to multi-class classification, there might be some problems here and there. But with the level of complexity, if you are a complete beginner and you don't know where to go, you just want to classify basic for classifying like cats and dogs, what would you gonna do is you just call a classifier, then you say Keras CV.models, then simple say image classifier dot from preset. Now, preset is pretty interesting thing to say. It is a constructor, and what it takes is it instantiates an object with a pre-trained configuration and optionally waits. So you can see I've marked in the red blocks here. EfficientNet v2 is actually the pre-trained model. ImageNet is the data set it's been trained upon, the weights from ImageNet, and of course, finally, the task. We want it to be a classifier. So you don't have to like write a whole lot of code telling your model that you want this data set with this weight and this task has to be performed. You just do it in a single line of code. If you are well familiar with how we used to write or call a pre-trained model, we used to like give efficient net, then in brackets we would say weights equals image net. So instead of doing whole lot of those things, you just have to write it in a single line of code and it's done, right? You can simply inference it from there. Of course, if you want to write it from scratch, you might want to go into some image pre-processing techniques like data augmentation, optimizer, tuning, model, writing your model, compiling and fitting. And here, what we did was earlier we told the model that we want ImageNet weights. And what we did was, if we are training from scratch, we are not using the pre-trained weights. We are training from scratch. So we told it that we don't need any weights. So no weights are involved here. And then you built upon the Keras net backbone. Efficient net backbone, and you build upon it with multi-head and just say like add few layers of sequential model, global max pooling, a dropout layer, and finally a dense layer. I think we used Caltech data for Caltech data here. That's 101 for that. Then is fine tuning pre-trained classifier. So fine tuning a pre-trained classifier is basically that, okay, your classifier, we were using EfficientNet. It's already trained on ImageNet. It knows how to detect patterns in the given images. And what you want to do is you have like good explicitly labeled cats and dogs data set, and you want to just pass it to your classifier, train on that, and you just want it to perform better than a generic classifier. So pre-trained backbones actually extract more information from your label data for cats and dogs, and it basically leverages the patterns that it had learned from ImageNet dataset and use it to give you better results, right? So if you see here, we use TFDS, that is TensorFlow datasets. We loaded cats and dogs here, distributed and split the data, got the number of classes, did a bit of resizing, pre-processing, and finally we had the data. So just pre-processing the data a bit more and using a pre-trained model, just fine-tune it on that. Then is object detection. Object detection is really interesting scenario when it comes to say self-driving cars like Tesla. They use a whole lot of object detection for bounding boxes and everything. And the major thing that is in object detection is just bounding boxes. So it provides you facilities to easily construct state-of-the-art object detection pipelines using Keras CV, and basically you want to identify, classify, and localize an object given an image. So you were given an image of say this whole image and you wanted a localizing of this car in a bounding box. So how do we do it is object detection. For this we use a pre-trained model, YOLO V8 detector, and from preset of course we told it that we want a YOLO V8 model, and the bounding box format here is XYWH, that is X coordinates, Y coordinates of the bounding box and the width and height of the image, right? And describes exactly what format of values you want in the boxes. So bounding boxes is basically this dictionary where you pass in the classes and the boxes. Finally, fine tuning. If you want to fine tune a pre-trained model, you first have to load the data using a data loader of your choice, do some augmentation. So here we were actually using YOLO V8 detector with architecture and ResNet 50 as a backbone. What we did was we resized the image to a size that was visible by 64, and to ensure that it is compatible with the number for downscaling operations that are done by the convolutional layers in the ResNet. So data augmentation is done, and then you finally define the model using layers, Keras CV dot layers, where we used a non-max suppression. That is basically an algorithm that comes in play in object detection, where you have like multiple detection or multiple detecting boxes for a single, like you can see here in potted plants, you have multiple detections of a single potted plants. You want to just remove that and solve the problem. So we use non-max suppression for that case. And finally, we say this is our pre-trained model from Keras CV.models, YOLO V8 detector model, and finally, the kind of format you want for the bounding box. Define the prediction decoder defined above, that is a non-max suppression, and finally use visualization API that is already imported from Keras CV to visualize the output. So if object detection is something of your choice and you are interested in that, there is a notebook by Ian Stenbit, who is a part of Keras team at Google, and he has this amazing notebook that is kind of a getting started notebook, and you can try, give it a try, and it has some like really basics that you can cover up in there, and I think that would be really amazing to try out. Then is data augmentation, another problem solution to Keras CV. So augmentation is, of course, a technique that makes your model most robust to changes in the input. So like whenever we have our data set, the images are usually in the simple format, like straight images, 90-degree images. And sometimes when we actually run the model within our real environment, the images are not as such. They might be flipped, they might be rotated, the lighting might be really bad, they might be cropped, the orientation might be wrong. So we really want our models to be robust to such changes on input data. And Keras CV has just the good API for that under Keras CV.layers, and it has number of functions defined for data augmentation. So you can do the kind of cut, you can do the kind of mix up you want, you can do some random augmentations, and we'll talk about few of them. So if you are familiar with augmentation, you might have been familiar with how you do augmentations. You have been doing augmentations like horizontal flip equals true, what kind of rotation you want, random flip or random crop and resizing, or random cutout where you're given an image and there is just a random black pixel box appearing for random cutout from that area. So apart from that, there are a few more that have been added in Keras CV that are really something that would help your model to perform better. So first is cut mix. Cut mix is basically similar to what we did in random cutout. You see here the red circle. So what we did here was there was a random cutout. The cutout was filled with black pixels. So instead of doing that, what they came up with was cut mix, where you replace that circular area with those black pixels with images that are already in the training set. So what that does, it actually helps you use your existing data to create more data. Following this replacement, the image classification labels get updated to be blended. So you have an original image and you have a mixed image as well. So you might see here that originally this was, I guess, a fruit pizza or something, and then you have another cut mix of image of a fish, right? So to call this, you don't have to write a whole lot of code. You just use this API KerasCV.layers.cutMix and you're good to go, right? Then another thing is mix up. So mix up is similar to cut mix, but what you really do here is you blend in the images together. So you might have two images and you blend them together in their pixel intensities as well as their classification labels. It is defined correctly as similar to cut mix. So you just call KerasCV.layers.mixup and use it as such. But the good thing about this is that you're using two images to blend together. So you're not losing on any data and you're training your model for multiple detections as well. Then is segmentation. So segmentation, especially semantic segmentation, is a bit different from normal segmentation, where normal segmentation you might have seen, and Usha also showed you, you are basically segmenting out different regions. So there might be, uh, say, a person sitting in front of camera, so you might be segmenting out the background or the human face or maybe the clothes, changing of colors and such of things. But semantic segmentation, you are basically for every pixel is assigned to a class label, so it makes it more detailed. For a layman's language, semantic segmentation is more pixel oriented, while normal segmentation is more about classifying a region. So I would suggest you to try the SAM model that is available by Meta. And it's pretty easy to use, and you can find a lot many Kaggle notebooks around it. I have tried it myself, and I've found pretty good outcomes. And apart from that, Google also have like old model that was a Deep Lab V3 plus. I haven't given this a go by myself, but if you are interested, you can go ahead and give it a try. So you can just have pass the number of classes you want and the input shape of 512 by 512 by 3, right? You can give it a try. So it basically works as you have the original image, you have the ground truth, and you have the prediction, and you can find out the loss. Finally, one of my favorites is image generation with stable diffusion. If you haven't heard of stable diffusion, or if you haven't tried stable diffusion or image generation with stable diffusion, I would suggest you to try, I think it's called Laura the Explorer on Hugging Face. I'll share the link shortly. It's called Laura the Explorer. By the name called Dora the Explorer on Hugging Face. You can just give in any prompt in form of text or a short text, and it gives you out a image that is generated. So what stable diffusion is I'll give you a brief about diffusion models. Diffusion models are basically noising and denoising models where the image learns to first add noise into the image, and then you denoise the image, and that's how it learns how to generate images. And with the prompt, you are actually conditioning the model to generate the right kind of image that you want it to generate using that prompt. So that's how prompt engineering and diffusion models work together. So it's implementation of stability.ai. It's a company that has this model text to image and under the name of stable diffusion, and Keras CV has implemented that in itself as well. So if you want to just create an image like this one I've already generated, you just need this code. The only code that is required to generate any image is on this slide right now. So if you want to just go ahead to your Colab, you can run it right now. You just need to import Keras CV, then write this model equals kerascv.models.stable diffusion, pass in the size like width and height of the image you want. JIT compile is basically a boolean that is for whether to compile the underlying models to XLA or not. This basically is to speed it up. Then you write images. You want, if you have worked with Hugging Face diffusers, you might be familiar with pipelines, or if you have taken any deep learning course around, like beta course around prompt engineering or stable diffusion, you might be familiar with pipeline. So it's similar to that model dot text to image kind of task you want it to do. Then you pass in the prompt. So photograph of a Grinch on Christmas, because Christmas is right around the corner, and the batch size equals 3. So it generates 3 images of Grinch on Christmas. So I've just taken just one of that, but there were 3 images. And of course, you use matplotlib to show the image. That's all. That is the basics of image generation. Just these simple lines of code, and you're good to go for image generation. No hassle of getting the API keys, maybe paying for API keys to OpenAI and all. Just simple basic calling of APIs using stable diffusion models. So when I talk about comparison with Hugging Face diffusers, Hugging Face diffusers are really good, but comparison to Keras CV, Keras CV has outperformed with Hugging Face diffusers, especially for warm start. So if you're not familiar with what is warm start is basically when you're just inferencing on a Tesla T4 GPU that is easily available on your Google Colab. What you're gonna do is you run Keras CV and diffusers, Hugging Face diffusers side by side, and you see the difference in the runtime. Of course, Keras CV takes less time, but these results are not comparable for cold start. So in contrast to hot start, warm start, cold start is basically that the model, you have to create the model, you have to compile the model, it will take a lot of time. So basically in diffuser or stable diffusion, the model compilation takes time, but the inference does not. Once a model is compiled, you can inference it again and again. It will take a whole less time than compilation. Of course, compilation is a one-time process. It will take some time to compile, but in a production environment, it is negligible. Of course, if you want to use stable diffusion API on Keras CV, it is still something that is work in progress and it's given on their official documentation. So they don't guarantee any backward compatibility for futures of APIs, but yes, you can give it a try. Apart from this, this whole presentation is built around the documentation that is solely given by the Keras team on keras.io. So if you have any doubts or you want to give it a try on specific problem like classification, segmentation, or image generation, you can just go to keras.io and you can search for Keras CV and you'll get the whole documentation right from how you want to get started or upgrade Keras to Keras 3, upgrade Keras CV or TensorFlow, and then how you can just get started with the simple classification task and you can run around with rest of the code. So all these things that I have taken from the documentation of keras.io, the resources are here. You can just take a screenshot of that. You have the Keras CV GitHub for where the Keras team has put all the code. And one thing, if you are looking for contributing into open source, so Keras CV, I think they have collaborations open if you want to contribute to this Keras CV or basically Keras 3. Classifications, object detection, image augmentations, segmentations, and image generation, stable diffusion. All those resources are taken from keras.io. So go ahead, feel free to jump around, take a look at how things work. And if you want, just for object detection, I have already shared this link, this notebook. You can just go ahead and try this notebook on yourself. Best part of Keras CV, I would say, is the multi-backend compatibility that is compatible with JAX, PyTorch, and TensorFlow. And the second best thing is that it is super easy to work around with that because Keras CV gives you a whole lot of freedom from just writing code to actually implementing things at a project level. At least you can build some end-to-end things that you can showcase for yourself. So I think that it was kind of a brief introduction to you for Keras CV. And unlike Keras NLP, Keras CV has been talk of the town and been working around with it. And go ahead, build some awesome things around. Use some pre-trained models already given in there. They'll be adding more pre-trained models around Keras CV and Keras NLP. Go around, try different things, learn from keras.io, implement on Kaggle. There are a whole lot of data sets that are available on Kaggle where you can just give it a try. And yeah, if you have any doubts, we'll be open for questions. Thank you so much.